deep divers. Today, we're taking a plunge into, well, the heart of darkness, I guess you could say. Black holes.
Sounds a little ominous, doesn't it?
A bit, yeah. But also pretty exciting, especially with this live science article one of you sent in about scientists possibly finding a ton of these missing link black holes.
Yeah, this research is making some waves in the astrophysics world.
So what exactly is so groundbreaking about this? Finding a bunch of black holes, I mean, isn't that kind of what astronomers do?
Well, yeah, but these are special. We're talking potentially hundreds of these elusive objects. To find this many at once, that's pretty unheard of.
And the article specifically calls out an instrument, DESI, as being kind of the hero in all this. What exactly is DSI and how is it helping us find these, I guess you could say, hidden giants?
DESI, it stands for Dark Energy Spectroscopic Instrument. Right. It's this incredibly powerful tool that we're using to map the universe, basically. See, it's focused on measuring the light from millions of galaxies. And within all that data, it can actually detect the signs of black holes hiding out in the centers of those galaxies.
Wait, so how does it do that? I mean, black holes are like famous for being invisible, right?
True. Black holes themselves don't emit any light.
Right.
But the stuff they feed on, that does. Think of it this way. As matter swirls around a black hole, it gets superheated, like crazy hot. And that makes it emit super bright light, and across a huge spectrum too, including X-rays, DSI. It can pick up on those emissions, even from billions of light years away.
So it's kind of like a cosmic spotlight shining a light on these invisible things.
That's a good way to put it, yeah.
And how many of these black holes has DSI helped find then?
Well, the researchers have pinpointed about 2,500 candidate dwarf galaxies that seem to have feeding black holes right in their centers.
2,500, that's a lot of black holes.
Yeah, it's a pretty big haul. But that's not even the best part. Within those, they've also spotted around 300 potential intermediate mass black holes.
All right, back up for a sec.
Yeah.
You keep saying intermediate mass black holes, and the article calls them missing links. What makes these so special?
Well, think about it like this. We know about stellar mass black holes.
Okay.
Those are the ones that form when really, really massive stars collapse at the end of their life.
Okay.
And those are, relatively speaking, small. Maybe a few times the mass of our sun.
Right.
Then on the other end of the spectrum, you have supermassive black holes.
Right.
These are the monsters, millions or even billions of times the mass of our sun. They usually hang out in the centers of galaxies.
So those are the two extremes, the tiny ones and the super huge ones.
Right. But the question is, how do we go from a tiny stellar mass black hole to a colossal supermassive one?
That's where these missing links come in.
Exactly. Intermediate mass black holes represent, think of it as a crucial stage in black hole evolution. They're that bridge between the small guys and the supermassive giants. And until now, they've been insanely hard to find. Like, we've only had a handful of confirmed observations.
So finding 300 of them is kind of a big deal.
Yeah, this could potentially, triple the number of known candidates. It could be revolutionary, honestly.
So basically, if we can study these missing links, we can finally figure out how black holes grow and evolve over, what, billions of years?
Exactly. And that's not all. See, this discovery has kind of thrown us a curveball.
How so?
Well, we found these potential missing links in dwarf galaxies.
Dwarf galaxies.
Yeah, they're much smaller and less massive than your typical galaxy.
Okay, so what's the curveball?
Well, the thing is, based on what we currently understand, most black holes in dwarf galaxies should be intermediate mass. But only a small fraction of the ones we just found actually fall into that category. So it's like, why? Does the type of galaxy a black hole lives in somehow affect its mass?
That's a pretty big question.
It is. And now researchers are trying to figure out, are there totally different ways that black holes form in different types of galaxies? Or does the environment around a black hole, maybe it messes with its growth in ways we didn't expect?
So instead of getting answers, we have even more questions now.
That's science for young. It's kind of the best part, actually. Each new discovery often leads to more questions and deeper mysteries.
Well, we'll definitely be keeping an eye on this story as it develops. But before we get too far ahead of ourselves, let's take a closer look at what these new findings could mean for, well, our understanding of the entire universe, basically.
Right. Let's zoom out a bit and see how this all fits into the bigger picture. Because this research, it actually has implications that go way beyond just black holes themselves.
All right, then. Time to shift gears and move on to part 2 of our deep dive. We'll be exploring how this black hole bonanza impacts our understanding of, well, everything, really. Galaxy evolution, the fabric of the cosmos, you name it. Okay, so we've established these missing link black holes. Pretty big deal in the astrophysics world, that's for sure.
Yeah.
But I gotta say, most people probably don't spend their days, thinking about black holes.
True, but that's what's so cool about this research. It has these implications that, like, go way beyond just theoretical physics.
Oh.
It touches on, like, really fundamental questions about our universe and how it became what it is today.
So you're saying even if someone's not like a black hole enthusiast,
Yeah.
they should still care about this.
Oh, absolutely. See, black holes, especially those supermassive ones, the ones in the center of the galaxies, they're not just sitting there. They play a huge role in, like, shaping the entire structure of the cosmos, really. They affect how stars form, how gas and dust move around, even the evolution of entire galaxies.
So they're not just these cosmic vacuum cleaners.
Nope. They're active players in the grand scheme of things.
Wow. So by studying these intermediate mass black holes, these missing links we were talking about,
Yeah.
we could actually learn more
Yeah.
about how those supermassive giants came to be and how they affect the galaxies they're in.
Exactly.
So could this even help us understand, like, our own galaxy, the Milky Way,
Yeah.
how it formed and all that over billions of years?
It could. Remember the Milky Way, it has a supermassive black hole at its center, too, Sagittarius A.
Oh, right.
By figuring out how black holes grow and, interact with everything around them,
Yeah.
we can start to put together a more complete picture of the Milky Way's history.
That's pretty wild. Like, we're going from looking at these individual black holes to understanding, like, entire galaxies, how they evolve and everything.
That's the idea. And this discovery, potentially tripling the number of intermediate mass black hole candidates we know about, that gives astronomers so much data to work with.
It's like going from a blurry photo to, like, a high-def full-on panorama. So what kind of specific stuff are astronomers hoping to learn from all this new data?
Well, for one, they'll be able to really dig into the relationship between, like, how massive a black hole is and what type of galaxy it lives in. That could tell us if different types of galaxies have different types of black holes.
And if so, why?
Exactly.
You mentioned earlier that this discovery threw a curveball, how the types of black holes in those dwarf galaxies
Right.
didn't quite match what we expected.
Yeah,
Could this new data maybe help us figure that out?
it could. With more data, astronomers can start to look for, like, patterns, correlations that might have been missed before. Maybe dwarf galaxies, their environments, they're different somehow, and that affects how black holes form and grow there.
Or maybe our whole understanding of black hole evolution is kind of off.
Could be. It seems like every time we get an answer, we just end up with more questions.
But isn't that part of what makes this all so exciting? We keep pushing the boundaries of what we know and finding new mysteries to solve.
Absolutely. And this is just the beginning, really. With instruments like DESI and, technology keeps getting better, we can expect even more discoveries in the years to come.
This all ties back to something you said earlier about the big implications of all this.
Yeah.
It's not just about black holes, right?
Yeah.
It's about understanding the entire universe, how it evolved.
Exactly. Black holes, even though they have this reputation for being, like, destructive forces,
Yeah.
they're actually crucial to the whole cosmic ecosystem.
Yeah.
They affect how matter is spread out, how stars form, even the structure of galaxies. So by studying them, we're basically studying, like, the fundamental processes that shaped the universe we see today.
It's kind of like everything's connected, huh?
Mm.
Even something is, I don't know, seemingly distant and weird as a black hole.
It is. As we learn more about black holes, we're not just, adding to our scientific knowledge.
Okay.
We're gaining this deeper appreciation for how complex and beautiful the universe really is.
That's a pretty cool thought. But before we wrap up this episode, there's one more thing about this discovery I want to touch on. Just the sheer scale of it. Tripling the number of intermediate mass black hole candidates. That's huge. It makes you wonder, what else is out there? What other secrets are hiding in space, just waiting to be found?
That's the question astronomers are always asking. This discovery shows us we've barely scratched the surface. The universe is vast. It's full of surprises. And with every new observation, every new technology,
Yeah.
we get a little closer to unraveling its mysteries.
All right, so we've talked about this incredible discovery, all these potential missing link black holes,
Right.
and we've kind of gone deep on what it all means for how we understand galaxies, the universe, the whole shebang.
It's been quite a journey, hasn't it?
It has. And it leaves you with this feeling of, like, awe
Yeah. Oh,
Like,
aspect.
what other secrets are out there?
Yeah, it's a powerful reminder that, honestly, we're just starting to explore the cosmos. There's so much we don't know, so much left to discover.
And you've mentioned DII a few times now. It seems like it's been, like, key to all these findings. Can you tell us a bit more about the technology behind it? How is it changing the way we study black holes?
Well, DSSI, it's really an incredible feat of engineering. It's basically a massive 3D map maker of the universe.
Yeah.
Imagine a telescope with, like, 5,000 robotic eyes, each one capturing the light spectrum from a distant galaxy.
5,000 robotic eyes. That's insane.
It is, isn't it?
So what are these eyes actually seeing that helps us find black holes?
They're looking for these, like, subtle fingerprints that black holes leave in the light coming from galaxies. Remember how we talked about matter falling into a black hole, getting superheated?
Yeah, go.
Well, that superheated stuff, it gives off intense radiation, and DSI can pick up on those emissions even if they're coming from, like, billions of light years away.
So DS is like a cosmic detective,
Yeah, I like that.
sifting through the light looking for clues.
Exactly. And the amazing thing is, it's not just looking for black holes. It's also collecting all this data on, like, distances, movements, what galaxies are made of. It's giving us this, like, never-before-seen view of the universe and how it's all structured.
It's like drinking from a fire hose of information
Yeah.
almost. So with all this data, with DSI, with technology always advancing, what kind of discoveries do you think we might see in the future?
Oh, man. The possibilities are, like, mind-blowing. We might be able to, like, actually witness the merging of supermassive black holes, see the birth of even bigger ones in the really distant universe. We might find whole new populations of black holes in places we never expected, things that completely change how we think they form.
And now we have the James Webb Space Telescope up and running too, right?
Hey.
Another powerful tool to look deep into space.
The James Webb is already giving us these, like, amazing images, and the data it's sending back, groundbreaking. It can see in infrared light, which means it can see through all that dust and gas that usually blocks our view.
So we have DSI mapping everything out on this huge scale, and then James Webb zooming in, giving us these incredibly detailed close-ups. It feels like, I don't know, a golden age for black hole research.
It does, doesn't it? And the best part, we have no idea what we'll find next. The universe is full of surprises. With every new discovery, we get a little bit closer to understanding, like, the fundamental mysteries of the cosmos.
Well, that's a pretty perfect place to wrap up our deep dive. We've journeyed to the heart of darkness, explored these missing link black holes, and considered the vastness of the universe and all the wonders it holds.
It's been a fascinating exploration.
And who knows what mind-blowing discoveries are just around the corner. To all our listeners out there, keep looking up at the stars and never stop exploring the mysteries of the universe. There's a whole lot more out there waiting to be discovered.